Hello students, so welcome back to another video. This is the second video of the series and we are continuing with taking up questions that are expected to come up in JEE Advanced 2026 and further examinations. So we are proceeding with the first question of today's video. So here is a question. A substrate is given and it undergoes three reactions one after another. First with CH2N2 with, you may say, a bit of heat. The second reagent is NaH. The third reagent is MEI, and it gives us a certain product, and the question asks for the degree of unsaturation of the product. Pause the video, give it a try, and then we'll proceed with the solution. Now, to proceed with the solution, the reagent that we are given, or rather the substrate, the starting material that we are given, is something like this. And with this substrate, the first reaction that is done is of CH2N2 with a little bit of heating. So the first step, the CH2N2 is basically something like this, and it has a lone pair on the carbon. So this lone pair attacks here and the bond rotates, and therefore it leads to the formation of something like O minus CH2 and N triple bond N, and here we have another benzene ring. Now if we look closely to this species, the N2 is a very good leaving group. So when we are heating this reaction mixture, this N2 actually leaves, and as a result a plus charge is generated on the CH2 group. Now this bond migrates to this CH2 group and we get an intermediate, something like this is CH2. We got O minus here. We have got a plus because this bond rearranged to this CH2 bond, and we have here the benzene ring. So this is a scenario so far, and this minus can back bond to form a CO bond. So the final product that we got in the first step is looking something like this. So we have got the double bond O, and we have the phenyl ring or the benzene ring here, and this is the first product, let's say the substrate A. Now let me clear the board and then we'll proceed with the rest of the two reactions. So this was the substrate that we got after the first reaction, that is, let's say A, and this is reacted with NaH, which is a strong base. Now we know that when a nucleophile or a strong base approaches a particular substrate, its preference of reaction would be first to any kind of an acid base reaction. The second would be an attack on a pi star if present in the system. Third would be the attack on the sigma star, that is, if any leaving group is present within the system which is linked with a sigma bond. And the fourth priority would be that of alpha hydrogen, which takes place in the case of aldol reactions. Now here we have to note that this hydrogen is significantly acidic because it has a conjugated benzene ring and it has a withdrawing CO group. So this hydrogen can be deprotonated with the help of a strong base like NaH. So when this reacts with NaH, we get deprotonation taking place and we get an intermediate of this kind. So this is the intermediate, and this when reacted, or this when tautomerizes, it first gives us something like this, and this in the third step on reaction with MEI, it gives OMe and a double bond here. So this is the final product that we require as our answer in this question. And the question asks for the degree of unsaturation of the final product. So we get benzene's degree of unsaturation is 4 plus 4, that is 8. This is a ring, so 1 9, and a double bond, so 10. So the answer of this question will be 10. So this was a very nice question that combined the reaction of CH2N2 followed by heating and the concept of the acid base taking phase first. So this is a very expected question that can come up in any of the future examinations. Let's proceed with the next question. So today's second question is a question from physical chemistry, and this correlates two chapters, solutions and electrochemistry. And this is a very fundamental question. These type of questions can be expected in JEE Mains as well, but there have been several fundamental questions that have been asked earlier in JEE advanced papers as well. So this is a good question that can come up in the future. So pause the video, give it a try. I'm showing the question on the screen, and then we'll proceed with the solution. So in the question it says that 2 moles of a non-volatile electrolyte, weak electrolyte XY is taken, and the volume used is 20 decimeter cubed, that is equivalent to 20 liters. And if the boiling point of the solution is found to be 100.08 degrees Celsius and the kb of water is 0.5, then calculate the conductivity of the solution in Siemens per meter inverse. And it is given that lambda m naught is equal to 500 Siemens centimeter square per mole, and we need to find the conductivity. And it is given that we can assume molarity equal to molarity. So to first proceed with the calculation of the solutions part, liquid solutions part, from there we can get the Van 't Hoff factor from the given data, and from there we can get the value of the degree of the dissociation of the weak electrolyte XY. So let's proceed with that calculation first. So we can clearly see that the elevation in the boiling point is of 0.08 degrees Celsius. So we use the equation 0.08 is equal to 0.5 kb multiplied by the molality, which is equivalent to the molarity. In this case it is given in the question, so it is 2 moles of solute in 20 liters of solution multiplied by the Van 't Hoff factor. So from here we calculate the Van 't Hoff factor, that is equal to 0.08 into 20, and half and 2 just cancel off, so this equates to 1.6. And now we know that for a weak electrolyte the Van 't Hoff factor can be written as 1 plus n minus 1 into alpha, where n is the total number of ions. So here the total number of ions is 2, so n minus 1 is basically 1 plus alpha, and this is equal to 1.6, so alpha is equal to 0.6. So we got the degree of dissociation as 0.6, and now we'll proceed with the calculation of this electrochemistry part. So to proceed with the calculations of the electrochemistry part, it is given that the lambda m naught, that is the molar conductance at infinite dilution, is 500 s centimeter square per mole, and we've just found that the degree of dissociation is 0.6. So we know that alpha is equal to lambda m by lambda m naught. So from here we get the molar conductance of the solution as 0.6 times 500, that is equal to 300. Now this is the molar conductance, and we need to find the value of conductivity, that is kappa, and we know that molar conductance is equal to kappa by molarity multiplied by 1000. Now if we place the values here, we get 300 is equal to kappa, that is the conductivity, by the molarity, that is 2 by 20 multiplied by 1000. So this evaluates to approximately kappa is equal to, we get here 3 into 10 to the power minus 2 Siemens per centimeter, and we are required to give the answer in Siemens per meter. So 3 is the final answer, because you can do the conversions required. It is centimeter inverse and here it is meter inverse, so the answer would turn out to be exactly 3. So the answer to the second question is 3. And these were the 2 questions for today, and do tune in every day to get more such interesting questions that you must solve during your preparation phase for the JEE Advanced examination. And make sure to subscribe and click the notification button so that every day at 8 o'clock in the morning you get the notification of these questions, and you make the habit of solving good questions every day. Keep learning.